Hello, and thank you very much for coming to this session about how to reduce your attack surface, your software's attack surface, when using third-party components. How many of you don't use external components, third-party libraries? Great. So everybody uses. And in today's modern software development, using external components, external APIs, open source libraries, this is the de facto standard. Not only this saves time, but in the case of libraries with security embedded in, it can reduce the security design flows and implementation flows. However, when these are not implemented correctly nor managed, your software is at risk of being breached through these vulnerable components. In this session, we are going to explore a few techniques to help you get in control on your software and the components that you bring into your software in order to reduce the risk of your software being breached through these vulnerable components. My name is Katy Anton, and I come from a software development background, just like yourself. I currently work as application security consultant at Veracode, a business unit within CA Technologies. So I am the person that when you developers get that huge report, either from static code analysis from pen testers, I work with developers to help them implement the correct solution. I'm also a project co-leader for OWASP Top 10 Proactive Controls. This is a list of security controls for developers to help them write a little code more secure. For those that are not aware, the OWASP stands for Open Web Application Security Standards. It's a non-profit organization focused on improving the security of the software. But first, I want to clarify what I mean through vulnerable components. When I'll talk as part of this presentation of vulnerable components, I refer to those vulnerabilities that are published in databases like NVD, which stands for National Vulnerability Database. They are available for everyone to see and understand what is the exploit. Furthermore, there are also ready-made exploits and databases of exploit like ExploitDB. And in this scenario where you have the vulnerabilities that are explained and easy to understand, but also you also have exploits ready-made, this makes it very easy for hackers to put all this information together, to optimize it, and depending on the type of vulnerability, to automate those. In fact, half of the exploits take place between 10 and 100 days since the vulnerability was publicly disclosed. In the case of Equifax, which is one of the largest data breaches, which has affected over 145 million people worldwide, according to the latest number, the vulnerability was disclosed in March, and it took 2 months to breach Equifax. And the common problem around this is the age of the components. According to a survey from Synopsys, 45% of components are over 4 years. 4 years in the age of software is an old age, because in that period, a lot of vulnerabilities have been disclosed. So we end up with old components that have a high level of vulnerabilities in there. In the case of Java applications, according to the latest state of software security from Veracode, 88% of Java applications contain at least one component with one known vulnerability. So we are talking about a large percentage of the software. Great, so one of the things that I do, I help developers to improve the security of the software, including fixing this type of vulnerabilities. Vulnerabilities in components. And the common problem that I see is the way they have been implemented in the first place. Let's continue the following structure, where you have your own code, but now you bring as well a third-party component, which depends on a library, that depends on another library, that depends on another library. And now you start implementing functionality from this code. And you implement it into a module, then another module, then another module. As you can see, this is a complex structure. And this is one of the problems. It's not the easiest to test. In this structure, you might apply a few manual tests, but they are going to be limited in scope and time-consuming. Then it's difficult to understand because if you, as a developer, get into this structure, you would not understand of what are all the parts that can be affected. And you can change a bit of code in one part of the software and you break in another part just because you were not aware in the first place. So it's very easy to break as well. And because of the complexity, it's difficult to maintain and upgrade. And now a vulnerability has been reported and might not be even in the main library, might be very well in a dependency. So in this structure, how can you understand of what's the risk of your software when this vulnerability has been disclosed? Because if you are not affected, then you need to do nothing. But if you are affected and your software is at risk, then what are the security controls that you must put in place in order to minimize the risk? And if you understand the security controls, then where are you going to exactly change the code? In the case, when bringing in third-party components, you can easily end up having the third-party code touching your own software into tens, hundreds, or even thousands of points. In the case of cross-site scripting remediation, you can easily get into thousands of points. So where exactly are you going to apply the code changes to fix your code? And how long is it going to take you in this structure to change the code in all of those hundreds of points? From a security point of view, all of those touch points where the third-party code touches your own code also represent extra attack vectors. And they add up to your software's attack surface. So to define from a simple definition from Wikipedia, the attack surface is the sum of your total points that an attacker can use to get data into or extract data from your application. So let's go back to our structure, where now we have this vulnerable component that is part of your application. And you have this vulnerable component that touches your code into tens or hundreds of points. These now represent extra attack vector that can be used by hackers to get into your software. There are extra attack vectors, which increases your attack surface. And you have to remember that a hacker needs only one vulnerability to bring down your software. You, as developers, you have to defend everything. So you have to apply controls for all of those points. Because the larger the attack surface, the more ways for the attacker for hackers to get into your software. The more ways for hackers to get into your software, the more difficult for you is to defend because you have to defend everything. And this is actually, so in order to actually reduce the risk of your application, you have to keep your attack surface at a minimum level. And this is actually a security principles. Keep your attack surface at minimum level. So in the case of this, when you actually end up with a vulnerable component into your software, you have to bear in mind that when you bring in that component into your software, you must do it in such a manner that you have a reduced attack surface. Next, I'll go through 3 examples in order to give you an understanding of what I refer through external component. I don't necessarily mean open source libraries. I'm referring to everything that you bring into your software and you are not aware of. So I'll go through the example of a simple library, like a login library. Then the next I'm going to discuss external APIs. They are, again, external to your software. And they can be another source of attack. And then libraries and packages that are developed by another team within the same company. And this is a common practice in large companies where you have one team that develops a package, and then that package is reused on multiple applications within the same company. So I'll start with the first example, which is implement a login library. This is a simple example, and probably most common to many of you. In this case, when you bring a ready-made library, you'll end up with a wealth of functionality. And you'll have, for example, in the case of a login library, multiple logging levels. Most likely, your software does not need the entire functionality, does not need all those logging levels. So probably for your software, you'll need only a small subset, let's say debug, warn, and info. For this scenario, when you bring in a library, but you don't need the entire set of functionality, you need from that library only a subset. A good design pattern to use is a simple wrapper. What this design pattern helps you to do is to expose into your software only the functionality that you need and helps you to hide unwanted behavior. It also helps you to reduce your attack surface. The wrapper becomes the one point that if you need to add extra security controls, in the case that new attack vectors are discovered, that's the point where you need to change the code. It also documents of what you use and how you use it. So you have a good understanding of what is used in your software, gives you more control. But when you bring in a library, you must always test the functionality that you bring and you expose into your software. So for this, never trust, always verify. And this is another security principle. Never trust, always verify whatever data you bring into your software, whatever functionality you bring into your software. For this, you should create tests to test that functionality. Unit tests, very good as well. To create a test costs you nothing. You must understand the functionality that you bring into your software anyway. The tests are a good way and an isolated way to gain that knowledge. In production, your software is not going to be used, will be abused. Let's consider the case of an e-commerce application that has a price. Usually, everybody enters the price, and the price should be positive. So you would expect to have a positive price. But what happens if somebody enters a negative price? How your software is going to behave in that case? What happens if somebody enters various characters into the price data? You should create tests for both use and abuse cases. This gives your software the resilience required for a production environment. And by putting these tests for both use and abuse cases into your software, you implement into your software the mechanisms for the software to respond to possible identified attacks, and then reduce the risk, or depending on how your implementation is done, even eliminate that type of attack. The next example that I'm going to go through is to implement a payment gateway. So this would be the scenario where you bring into your software an external API. Now, in the case of e-commerce applications, it's likely that you will need to implement more than one payment gateway. So for this type of scenario, where you might need to, and each payment gateway from each provider will have its own methods, but your software will have its own set of methods. For this scenario, when you actually need to convert in a way from the provided interfaces to the required methods in your own application, you can use the adapter design pattern. And this, now this design pattern can help you. I gave the example of external APIs, like payment gateways, but you've heard a lot about the AI, so this applies to any kind of external APIs. This also helps you out. If you don't like that provider, you can easily change it. But the external API, like this says, it comes from a vendor. But the same principle applies again. You should never trust, always verify. You should never trust the data that comes from a vendor, even if it is a partner, because they might have been breached and they might not even know. So by putting the controls into your own software, you help your software of not being breached further. And there is a trend now at the moment where there is a trust, especially developers would trust external partners because there are agreements. And if they are breached, then that breach propagates throughout. So put extra controls into your software, test the functionality that you expose into your software, implement test cases for both use and abuse cases to give your software the mechanisms to protect against possible identified attacks. So if we are to recap, the adapter design pattern is useful for the scenarios when you need to convert from the provided interface to the required interface of your own software. It is easy to maintain because it has only one dependency, which is the adapter interface, and it can work with many adaptees. Great. So the next example that I will go through is the scenario where a team within the same company has created a library which is then reused throughout the company. And this can be a complex package for this scenario where you can actually have a complex system, but you need into your software only a set of functionality, then you can use the facade. The facade design, software design pattern helps you to simplify the interaction with a complex subsystem. It makes it, also it's very good for legacy applications. It's good with poorly designed APIs. It can it can hide away from the clients the details and reduces the dependencies of the outside code. So if we are to recap, when you start working with your software, the security of your software starts from the design, from the point when you have chosen on how to implement a certain component into your software. For those libraries, simple libraries, where you just need to expose into your software a subset of functionality from the entire set of functionality, you can use a simple wrapper. When you need to convert from the provided interface to your own interface of your own software, you can use the adapter software design pattern. And for each, when you have a complex subsystem, to simplify the interaction between your own software with that external component, you can use the facade. And all of this gave you that one point that helps you to get control of your external component. And if there are extra vulnerabilities, attacks vectors discovered into the external component, you have that one point where you can apply the extra controls. Also, they help you out to change to other APIs quickly without much effort. So until now, we have discussed about how to secure your software when you implement the components. And let's say that you have done it and you have reduced the attack surface, but it's equally important to monitor the external components because every day new vulnerabilities are discovered. And for this, you should automate the checks. Automate the checks for your components. In terms of open source tools, you can use for .NET and Java the OS dependency check, Retire.js for JavaScript, and PHP security checker for PHP applications. There are also commercial tools, but there is no excuse for you to not start at least with the open source tool to start checking your components of vulnerabilities in order to see what's the security state of your own software. What I would like you to take away today is that you should manage the software in such a manner that you take control of the external components that you bring into your software. And what I try to send you is not the open source libraries, it's also external APIs from partners, from vendors. Don't trust them. Implement them using the same security principle, never trust, always verify. And also components from other teams within the company. This helps, and especially when you're implementing a Teams package, a team that you know and you go to beer after work with them. It's not that having in place the same principle helps as well with the security state of your software because you just have another pair of eyes on that package. And also you should do it in a way to manage that the software is safe, but then stays safe over time. Have regular checks for your components that are part of your software. So if we are to recap the best practices when using external components is use library from trusted sources, first of all. When I say trusted sources, it's teams that know what they do, because security is difficult to do, and you still need to have good people developing the libraries. One is that they know what to do, and then the second one is, when was the last time that package was updated? If it was 2 years ago, then a lot of vulnerabilities might have been disclosed in a 2 years time frame. So teams that know what they do, and those libraries are regularly updated. The next one is when you bring your software, your external component into your software, encapsulate it. Encapsulate it to reduce the total attack surface of your software. Expose in your software only the functionality that you require and hide unwanted behavior. Regardless of the source of the component, never trust, always verify. Always test the functionality that you bring into your software, create tests for both use and abuse cases. Once you have brought your components into your software, regularly check them for vulnerabilities. New vulnerabilities are disclosed every day, so have regular checks. You can do this one by easily integrating it into your continuous integration in Jenkins or other tool of continuous integration, so they are automated. And once you have discovered vulnerabilities into the external components, regularly update them and even replace the obsolete libraries. So I think this is the part where we fail the most as developers on regular update these vulnerable components. So it should come as part of your nature, especially in more agile environments, to have these updates scheduled more often. Now, if you'd like to, so I just try to bring together the security aspect with the software design aspect. If you'd like to read more, a good start is Robert C. Martin's book about clean code. It has a nice chapter about boundaries. This will help you to have a good understanding about software design patterns when you implement them into your own software. But then have a look at the security by design to start learning about the security principles as well, and try to bring those together, the software design patterns and the security design principles. And if you are looking to the controls that you can put when new attack vectors are discovered, you can have a look at the OWASP top 10 proactive controls, which is the list of security controls for developers. And on this note, thank you very much.
Patching and updating, that's really one of the most important things, and use a current software and use your current modules and libraries if you can't wrap it properly. But one thing I learned at least is change to the dark side. It's easier to attack a system than to defend it.
Yes.
We got some questions. How to handle the Node.js apps and that install gazillions of other modules and libraries?
Right. It comes again to one, I was saying encapsulation, but you really need to have in place automated checks to check for the dependencies into the application. So that is the problem, especially in JavaScript, where you have libraries that call other libraries that call other libraries. So JavaScript is a good example. Java is another one where you have this kind of structure of packages. Yeah, monitor the vulnerabilities, have in place an implementation that allows you to quickly update that library or replace it. And the encapsulation is a good design pattern for that one.
I think that perfectly fits to the next questions. Is it doable for a mid-sized organization to verify security? What are the first 2 or 3 steps every organization should put in place?
Yeah, so for every organization, including the small ones, when you bring into your software a component, use components that are maintained and had recent updates. So that's one of those. Then implement it using a design pattern that allows you to encapsulate. Code review is very important. So I led development teams. For me, the code review is the smallest change that can bring the most benefit. You have a second pair of eyes that can see things that you, as the main developer, might not have thought about it. The next one is automate checks during your development in continuous integration. So use tools like Jenkins to connect, to bring in automated checks. So the OS dependency check is a pretty good open source tool for Java and .NET. So you can start with the open source tools as a first one. Then, as you grow as a company, you can go on to vendor tools. They'll give you more benefits, and you can choose one depending on the needs of the company, but you can start with the open source ones.
Thank you. I think that's important to add one too. There are loads of libraries and modules out there. If you use them, donate to the developers. They live from it, and so you can make sure that they can maintain and update those things. Don't just take it, give something back to the community. So you give and you take. I think that's a question of fairness and a question of openness. Yeah. So, Katy, I thank you for this wonderful presentation. That gives you a 15 minutes of break. That's your applause.
Thanks.